Okay, this example involves finding the equation of a couple of lines, using a few other ideas, I guess, and some formulas we've already talked about. So what they ask us to do is take this line, okay, and find two lines, both containing this point, one which is parallel to the original line and one which is perpendicular. Okay. Now these two ideas of parallel and perpendicular have to do with slope. So let's start with part A, but the first thing I need to do is find the slope of this line. Okay. It's kind of hard to see what it is just by looking at this equation, but it won't be hard if I solve this for y. Okay. So first of all, in fact, let me go ahead and erase. I think I might need a little bit more room on this one. Let me go ahead and find the slope of this line. Okay, so we got the line 4x minus 2y equals 3. So let's see, if I subtract the 4x over to the other side, I get negative 2y equals negative 4x plus 3. Okay, and then if I divide both sides by negative 2, I can get y by itself. Okay, so the original line they gave me is going to be y equals, and let's see, negative 4x over negative 2. Okay, it's going to be 2x plus 3 over negative 2. Well, that's minus 3 halves. Okay, so this is the original line. Okay, but importantly is that this line has a slope of 2. Now in part A they wanted us to find the equation of a new line which is parallel to this one. So the slope has to also be 2. Okay. Okay, now the new line contains the point 2, 1. So right now I'm pretty much ready to go ahead and use this point slope formula. Okay, since this line I'm supposed to find is supposed to be parallel to the one we started, the slope is 2. Okay, and since it's supposed to contain this point, there's my x1, there's my y1. So just plug those things into this formula. Okay, so this is the equation of the parallel line they asked us to find. Okay, well, again, we like to write it so it's solved for y, so I'm going to go ahead and do a little bit of algebra here. Okay, so I get y equals 2x minus 3. Okay, so this line is parallel to the original one and contains the point 2, 1. Okay, now let's go over to the next example. Okay, the next part B. Okay, part B is a very similar problem, but asks us to find the perpendicular line, okay, to the one we started, containing this point. Okay. Okay, so let's go ahead and erase this and go to part B. And remember now it's perpendicular. Okay. Okay. So the slope of our original line was 2. Okay. What about a perpendicular line? Well, there's this formula in the book that the slope of a perpendicular line is going to be negative 1 over the slope of the original line. Okay. So if our original line had a slope of 2, the slope of this perpendicular line is going to be negative 1/2. Okay. So that's all I really need here. I just need the slope of what I'm trying to find out. Okay. So again, I go back to this point slope formula, y minus y1 equals m times x minus x1. Okay, it's going to be very similar to the one I just did, but now the slope is negative 1/2. Okay, so I'll go ahead and erase some of the scratch work. Okay, well, I've got y minus 1, that's my y coordinate, equals the slope, which is negative 1/2, times x minus 2. Okay. So I've got to simplify this, solve this equation for y. Let's see, I've got y minus 1. Okay, that's negative 1/2 x, and negative 1/2 times a negative 2 is going to be positive 1. Okay, so now I can add 1 to both sides. And get y equals negative 1/2 x plus 2. Okay, so that line is perpendicular to the first line, okay, and contains the point 2, 1.